Here, we have a red LED. LEDs, or light-emitting diodes, are small devices that produce light when provided an electric current. Let us figure out how to properly use one in our next project. We don't know much about how this specific LED should be used, so let's start with its datasheet. As the name implies, all LEDs are diodes, which means that polarity does matter. According to the datasheet, the positive connection, or the anode, is the longer leg, while the negative connection, the cathode, is the shorter leg, or the side nearest the flat side on the lens. Sounds simple enough. Let's take this 5-volt power supply and wire it up as the datasheet says. And immediately self-destructs. Why is that? Let's get a new one and dig a little more into the datasheet. We find that the typical forward voltage of the LED, that is, the minimum voltage required for the LED to turn on, is around 2 volts, and its maximum current is 20 milliamps. Scrolling down, we can even find a graph that describes how much current flows through the LED based on the forward voltage, and it's clear that the voltage range is very narrow. Inside this range, the LED is on with varying degrees of brightness. Anything less, it turns off. Anything more, it goes poof. And as we can see, 5 volts isn't even on the chart. But this is all we have, so what do? We need something that can absorb the difference in voltage between our power supply and the LED's forward voltage while providing the desired current. The simplest solution is to use a resistor, since the amount of voltage that the resistor will drop depends on the current that's flowing through it. Let us first decide how much current we want to supply to the LED. We typically design LED circuits to draw around 1 milliamp, so the LED doesn't blind you but isn't too dim either. Let's go back to the example. Technically, we're supposed to carefully read the graph and determine the exact forward voltage that will give us the desired current. But in real life, no one has the time to do that. So we usually go with the typical value in the datasheet, which is 2 volts. If we want to run this LED with a forward voltage of 2 volts off of a 5 volt supply at 1 milliamp, we need a resistor that will drop 5 minus 2 volts, 3 volts when 1 milliamp is flowing through it. We can use Ohm's law to calculate exactly what we need the resistance to be, and in this case, we need a 3 kilo ohm resistor. Sometimes, if your calculated resistance value does not match available resistors, it's okay to go a little higher or a little lower, which will make the LED slightly dimmer or brighter, respectively. Try it for yourself. Great. Now we can turn on an LED, but that's boring. What happens if we want to dim it? Or drive some seriously powerful LEDs? Or even drive a giant grid of them like a computer monitor? Think of the possibilities.